Hey folks, welcome back. Um, Today we got a pretty kind of interesting day for you. I'm going to talk through some of that torque on a current loop help. I know some of you reached out to me through the Google Doc and said, "Hey, is there any way you can explain this or help me with this?" So that's how I'm going to start off lecture today. And then the picture on the left there you see, that's basically a simple alternating current motor. We're going to build one of those today. So you'll see a circuit set up and all that good stuff as we go ahead and go through that one. Okay, so let's start it up. So we asked a question in the first one here. What direction is the torque going from here, from A to D? Now, the blue lines on here were meant to be field lines going from, or the magnetic field lines, I'm sorry, going from north to south. All right. The current you can see by the smaller kind of black arrows. Actually, also you can see them on the loop of wire inside that actual magnetic field there. Okay, so when we see A to D, if our magnetic field is going this way, well, so is our current. So because those two are traveling in the same direction, there is no magnetic force there. All right. What we have to get away from at times is that a small percentage of us are still talking directions, north, south, east, west. There are no directions on here just because directions become really, really confusing for us as far as looking at that. So what we're going to say in this case is there is no force. So when you see that on Thursday, that'll be what you're looking at. Okay. What direction is a force from point B to point, or point D to point C? All right, so that's going up the right side here now. Because we have field lines, because we have a straight line, we can still use that right-hand rule here again. Okay, so what we see is my field is pointing towards that south end of that magnet. The current, which is my thumb, is pointing up at a 90 degrees towards the kind of the top left corner. So what ends up happening is that I see that my palm right here is going to be going down into the drawing. Okay. So once we know that that thing's going to go into the drawing, again, that helps us to understand that there is going to be some movement possibly. All right. Because there is force on this one side. All right. When we look at 3, from point C to B, from point C to B, again, we see that field line going that way, right? Now our thumb or our current has to be going backwards. We can't physically do that, okay? Once again, this current is going parallel. It just happens to be going the opposite direction of the field, of the B field, so there is no magnetic force, all right? For 4 then, from point B to A, and we could look from A to B, either way, whichever way you want to look at it, all right? So again, B field is going from the north to the south, correct? And then what we see is that current, well, this was on the other side, so this was from point C to D, but from B to A, we actually have to flip it because it's going backwards, kind of almost out of my screen, so to speak. So what that does is that tells me I have to lift this thing. This is going to go up, almost out of the drawing, okay? And what we'll try to do is make it so that it's not on a skewed angle like that. We'll try and get it so that it's a lot flatter for you and almost basically in your face, so to speak. All right. So what this leads us to now, all right, from the perspective of an ant sitting on point G. So if we were just sitting on point G, even if we weren't an ant, even if we were just us, okay, what you're going to see here is that you have 2 sides that are doing nothing. They have no force. That's the top side, that's the bottom side, closest to us at point G from A to D, okay? Then you got a side on the right that's doing something and a side on the left that's doing something. Most of us, once we got to this point, we were actually in really, really good shape. We had all of these pretty well correct. We had these running the correct way. Now we just had to look at this drawing and say, okay, what is actually happening here? Well, what's happening here is that right side's going down. That left side's going up. So if I look at that and think, how is that thing going to rotate? if I'm looking at that right side going down and that left side going up, what I should see is this will cause a clockwise rotation or a clockwise torque twist. Okay. So again, right side's going down, left side's going up. So in this case, what I see is that my left finger is moving towards the 12 o'clock hand or the 12th part of the clock, right? So it's moving up and around towards it. Okay. Um, Again, with that one, I just like to take it out and look at it and say, okay, which direction? Is it going this way? Is it going this way? Right? In this case, it's going clockwise, so we're going to produce that spin that way. Okay? Hopefully that helps. Let me know if you're still confused with that, and we'll try and figure out something that we can do with that one. Okay? All right. Then here we go. The world's simplest DC motor. All right. So what you're going to see is we're going to take a plastic cup, just like on the right side here. Okay, I'm going to move myself. Sorry. We're going to take a plastic cup that we've taped paper clips to, right? You'll notice there's a magnet on there with a paper clip on the top. The paper clip is acting as a way to hold that magnet. And then we got a loop of wire that we're going to hold there as well. Okay? And the paper clips are basically meant to make it so that that loop of wire can sit above that magnet, all right, and get kind of spun, so to speak, is the hopeful thing, all right. So the goal out of today is to try to create a spin out of this basically loop of wire, all right. I'm going to give it an initial start and then see if it runs from there, okay. So here's how we did it, all right. So what I did was I took a loop of wire, or basically a piece of wire, wrapped it around a whiteboard marker. Okay. In the past, I've used my finger. I've used my index finger or something like that. Basically looped it around until I had some tails. Once I had some tails, then what I did was I tried to attach those tails by turning part of that wire so that it was off of there, okay? So what you can see maybe is that's what I've got there, all right? I'm kind of in that shape right here, okay? Now, what I want to do is I want to take this loop of wire and I want to try and make it so that I can spool this one side so that it's perfectly parallel and in line with the other one. Parallel is probably not the right term. I want it to be perfectly in line with that thing. Okay? So that's what I'm doing right now. All right. And so what ends up happening here is I've got it so that it is, you can see it there, it's got it on each side. All right. Trying to have it be so that it's vertically perfect. Let's see if I can get it on my shirt. It's tough to see. It's pretty small. Okay. Once I have that, I've already pre-stripped the wires. What I want to do is I want to get it halfway stripped off. The reason I want to get it halfway stripped off is because when that part of the wire comes in contact with the paper clip, it's going to allow charge and current to run through it. When the part that's not stripped comes in contact with it, it's going to basically block it and provide basically a stop for that current. Okay. It'll also allow that current to flow through here. Once in that magnetic field, once we get it on the sides, what we'll see is that's going to cause it to twist. And if we can get that motion to continue, what'll happen is that the side that's stripped will come into contact every so often, meaning that every other rotation or every about half rotation, it'll come in contact and it'll give it current through here, and it'll cause that thing to torque and to twist and to rotate. Okay, hopefully that makes a little bit of sense. All right, there's my setup. Obviously this was a setup at school in my old classroom, but what you can see is we got a battery eliminator. Battery eliminator is going to be set to 4.5. I've got my red cable coming from the positive portion running right to that plastic cup. with the paper clips on it, I then got a trio of light bulbs. All right, those light bulbs are connected in parallel. Now, I didn't grab paper clips just because I was kind of lazy. Sorry about that, I know. So what I did was I just took the ends of them and just wired them together. I just wrapped them together and then tagged them into alligator clips. Okay. Alligator clips, then the wire goes to the multimeter. I'm going to set the multimeter up for a current just to see what my current reads for it. And then the end of the circuit is the black portion of it running back to the battery eliminator. All right. So here's what I'm going to do for you. I'm going to run over to my lab area and show you my setup and see if we can get this sucker to run. Okay. So I'll see you in just a second. All right, folks. We're back here. I'm just showing you my setup. Taking my webcam, kind of showing you around, seeing what's all here. All right. I got my multimeter, as you can see, set up at current for us as milliamps. There's my plastic cup with the cables connected to it and paper clips on the side. There's my wires sitting in a parallel. All right, and here is the master of ceremonies. All right, as you can see, what I've got here is it should be pretty well balanced on the sides, pretty even throughout, singular line through. If we rotate it so that we get it like that, that looks pretty darn good. Okay. So what I'll do here now is I'm going to tighten up a few things here. Just make sure that's good and stuck on there. All right. Oh, make sure that's off for a second. Okay. Put that in through there. Make sure it's pretty centered. All right. Let's flip on the power over there. And, well, okay. So we've got the lights running. All right. We've got current going through there. Okay. But here's the thing. It's not spinning. All right. Well, the hope is that what we can get going here is we can get this thing with one little push to be able to now start to spin. It's so close. What you see is lights are flickering. They're telling me that that current is alternating throughout. We can see that the current running through it, it's bouncing all over the place, which is exactly what we want it to do because it's getting some and then it's getting some current and then losing some current. And that's spinning, folks, pretty darn good. Pretty darn good. So, well, all three together is pretty successful. All right. So here's what I'm gonna have you do. All right. Hop over on that Google Doc, do the analysis of the lab, and we'll talk to you tomorrow. Okay. Hey, have a great day. See you tomorrow.